Hello, this is Alex from the 3D Applications team. In this image analysis example, I'll show you how to compute the distribution of pore diameters in a foam sample and how to define a custom measure to compute the sphericity of pores. To follow this tutorial, you should be familiar with basic manipulation of data within Avizo. This section is divided into the following 4 steps: pore detection, pore post-processing, custom measure group definition to determine the distribution of pore diameters, and custom measure definition to compute the sphericity of pores. The image data used in this example is acquired by microtomography. It represents foam that consists of material and pores. Pores will appear with dark levels in the image with low intensity voxels. The material will appear with luminous levels, or high intensity voxels. Start by loading the data from the Avizo directory, Data, Tutorials, Image Processing Advanced, and then foamporo.am. If auto display is turned off by default, connect an ortho slice to display your data. Our first step is pore detection. Connect an interactive thresholding module to the data. Set the intensity range between 0 and 50, and then press apply. You should hide the interactive thresholding module and attach the ortho slice to the foamporo.thresholded dataset. As shown, thresholding the image between 0 and 50 gives a binary image, where intensity levels equal to 1 are equal to pores or porosity, and intensity level 0 is equal to support or material. Our second step is pore post-processing. The morphological opening operator applied on a binary image gives another binary image where the small objects are removed. Object boundaries are smoothed, and some objects may be disconnected. Connect an opening module to this binary image. Set the size in pixels port to 1 and press apply. Move the ortho slice to the new dataset, and you can see the effect. Applying the morphological opening on the previously computed pores binary image gives a filtered image where noise and artifacts are reduced. The Separate Objects module detects surfaces that separate agglomerated particles. These surfaces are subtracted from the initial image. We're going to use that module now, so connect the Separate Objects module. Set the marker extent to 1, and then hit apply. Again, you should move the ortho slice module to the new dataset, and you can see the effect. Our third step is custom measure group definition to determine the distribution of pore diameters. The Avizo label analysis module allows computation of a set of measures for each particle of a 3D image. Once the individual analysis is performed, a histogram of a given measure may be plotted in order to produce a representation of the measure distribution. To do this, connect a label analysis module to the separated binary image. Set foamporo.am as the intensity image. In the measures port of the module, the basic is a group of pre-selected native measures. It might happen that you don't need all of the measures of the basic measure group, or you'd like to bundle a different set of measures in the analysis table. For these cases, you can create your own measure group. For a given particle, the equivalent diameter measure computes the diameter of the spherical particle of the same volume, so the equivalent diameter is given by the following formula, where the equivalent diameter is equal to the cube root of 6 times the 3-dimensional volume divided by pi. press on the configuration button of the measures port, these three dots, and a panel will open where you can select the measures groups. Create a new measure group by selecting the dedicated button next to the measure group selector. A window will pop up asking you to name it. Let's call it diameter. Press OK. Select EQ diameter in the native measures list under geometry. Add it to the group. The new diameter group containing only the equivalent diameter measure is now selected in the measures port of the label analysis module. Click the Apply button. A new label image data object, foamporo.label, is created in the project view, and the Tables panel is displayed, showing a spreadsheet-style table of results. The analysis foamporo.label analysis is also created in the project view. Select the EQ diameter column in the lower spreadsheet. Press on the histogram button of the toolbar. A window opens displaying the EQ diameter histogram. Our fourth step is a custom measure definition to compute sphericity of pores. Avizo provides a set of predefined native measures, but it's also possible to save user-defined custom measures. Select the Label Analysis module. In the Properties panel, press on the Configuration button of the Measures port. Again, the button with three dots. Choose the diameter group if it is not yet selected. Create a user measure by pressing on the dedicated button. Name it Sphericity, and hit OK. The Measure Editor panel opens. Sphericity is a measure of how spherical an object is and can be represented by the following formula. Sphericity is equal to pi to the 1/3 power times 6v to the 2/3 power, all divided by a, where v is the volume of a particle and a is its surface area. It is the ratio of the surface area of a sphere with the same volume as the given particle to the surface area of the particle. The sphericity of a sphere is 1, and by the isoperimetric inequality, any particle which is not a sphere will have a sphericity less than 1. Sphericity can be expressed with respect to Avizo measures as the following. Pi raised to the 1/3 times 6 volume 3d raised to the 2/3 power divided by area 3d. You can either type that in manually or you can click and drag the measures from down below. Press close. Select sphericity in the user's measure and use the arrow button to add it to diameter group. Click OK, and then press the Apply button in the label analysis to run diameter again, but now with our new measure. The analysis panel is updated and displays the EQ diameter and sphericity measures. Note that using a custom group to select only the needed measures can help to speed up the analysis process. Also note that user-defined data, such as custom measure groups or custom measures, are persistent at the end of a work session as local settings, so they can be retrieved when you restart Avizo. These custom data are also saved in the project scripts. And then finally, on the topic of sphericity, it is important to mention that the sphericity computed could be superior to one for small pores, for example, those composed of only a few voxels. This is due to the fact that an area 3D measure is computed with chordal approximations, which gives generally a better approximation of the area, whereas it is not the case for volume 3D measures, which do not use any approximations. Avizo offers powerful ways to define custom measures. See our user's guide and reference guide for further details. You can load all of this information as a project in this folder by typing in customer measurements, and then it's this option right here. In summary, in this example, we've shown how to do pore detection, pore post-processing, custom measurement group definition to determine the distribution of pore diameters, and custom measure definition to compute the sphericity of pores. Thank you very much.